problem 4.2.9. So the question is that suppose we have a approximation method that if we use the steps as h, then the ah is going to be approximation of m for every positive h, and the expansion is like this. So this is the OH method, because by approximating m using NH, we're going to have this residual term. So now this K1, K2, they are constants independent of H. The question right now is to use the values n of H over 3, n of H over 9 to produce a OH cube approximation to the M. Okay, so this is just a kind of variation of the Richardson method we derived in class. Instead of having H, half H, and a quarter of H, we're going to use this 3 and 9 instead. So the idea will be the same as before. What you need to do is just to look at these expansions. So this is what we're given, like here. And now if you use the third of H instead of H, then you're going to get this. Okay, remember that all the H are replaced by H over 3. So that's why I have these terms right here. And similarly, if you do the H over 9, you're going to have this. Okay, now the question is how we're going to use these things to construct a better approximation of the M. Now let's look at the first two right here. So as you can see, if we're going to have a higher order approximation of M, we can see that we can multiply this row by 3. And then we have the purpose of multiplying by 3 is that here, by multiplying by 3, this will, taking the difference of these two, the H term will be cancelled. The OH term is going to be cancelled. We're going to have a H square approximation. So by doing that, we're going to have, as we said, I multiply 3 to this row and subtract the first row from this row. Okay, so that's how we're going to get this. Now you can see by dividing both sides by 2, I can simplify that new formula, which is just this. Okay, from the previous row. Okay, just divide both sides by 2. So this part is going to be our N2H, because that's going to give us a approximation of M with order of OH square, which is better than the original approximation N. Okay, we're going to call this N2H. So if N2H is this, we substitute H here with H over 3. So what is going to happen is that this right now is going to be N2 of H over 3, and here this H is going to be by H over 3, this H here is going to be replaced by H over 3. So we're going to end up with this one here. Okay, now comparing this row and this row. So for these two rows, if I want to cancel out this, what I need to do is to multiply this row by 9 and then subtract this first row from this row. Okay, after I multiply by 9. And by doing that, we're going to end up with this. So now you can see that this is the OH3 method, because if I can figure out these two values, I'll going to get an OH3. Okay, so now what we need to do is divide both sides by 8, and then recall the formula for N2. So N2, we're going to have N2 H over 3, and also N2 over 3 H over 3. But N2 of H over 3 depends on, so N2 of H depends on N of H over 3. So N2 of H over 3 is going to be dependent on N of H over 9. Okay, so we just need to plug in those formulas we got earlier, and then we're going to end up with this plus OH3. So expand everything. These are the 3 values we can use, right? And it is a formula that's going to give us approximation with error of order H.